Today, we're going to tackle a really messy problem. How in the world do you clean up the absolute toughest industrial wastewater? Well, the answer, and you might be surprised, is as simple and elegant as a bubble.
Okay, so let's start off with a little bit of a puzzle. What could possibly connect, say, a brewery making your favorite beer, a meat processing plant, and a huge oil refinery? They seem totally different, right? Well, here's the thing. They all produce incredibly contaminated wastewater as a part of what they do. And believe me, dealing with that water is a massive challenge, both for the industry and for the environment. So let's really dig into this industrial wastewater problem. I mean, we're not talking about just slightly dirty water here. This stuff is a complex soup of pollutants. For these companies, treating it isn't just a nice thing to do, it's an absolute necessity, driven by some really strict environmental regulations and, frankly, the huge costs if they don't comply. Okay, before we get to the really cool solution, let's just get some of the jargon out of the way. You're going to hear about TSS, that's total suspended solids, basically just tiny floating bits. Then there's FOG, which is, you guessed it, fats, oils, and grease. And finally, you'll see BOD and COD. These are super important measures of pollutants that can just wreck an aquatic ecosystem if you don't treat them. But you know, for every messy problem out there, engineers are always searching for an elegant solution. And in this case, that solution, quite literally, floats. So let me introduce you to the hero of our story, dissolved air flotation, or DAF for short. The whole idea is just genius in its simplicity. It uses millions of microscopic air bubbles that latch onto all the contaminants and lift them up to the surface. Just think of them as tiny little life rafts for all that unwanted gunk. Okay, so how does this technology actually turn that filthy water into clean water? Let's break down exactly how it all works. It's really this beautiful five-step dance. First, a small stream of already clean water is recycled and put under a whole lot of pressure with air. Then, and this is the magic, when that pressurized stream is released into the main tank, the sudden pressure drop creates what's called white water. It's millions upon millions of microbubbles. These bubbles are the key. They grab onto all the solids and grease, floating everything to the top. From there, a mechanical skimmer just scrapes that layer of sludge right off, letting the clean water flow out from the bottom. Simple, right?
And this schematic here shows you what's going on inside. Now look closely at those angled plates in there. Those are called plate packs, and they are an absolute game changer. What they do is dramatically increase the surface area for separation, which means you can clean way more water, way more efficiently, and in a much smaller machine. But, you know, this isn't a one-size-fits-all kind of solution. The basic DAF principle is adapted into different designs, and each one is engineered to solve a very specific set of challenges. This table from FRC Systems gives us a great little overview. You've got the PCL series, which is this tall vertical design that's perfect for high-flow situations where you don't have a lot of floor space. Then there's the PCS series, which is so compact it can be built right inside a shipping container for mobile or remote jobs. And finally, the PWL series. That's a long, low-profile tank designed for wastewater with really heavy gunk in it. And this shot just illustrates that form follows function idea perfectly. See, on the left, the PCL model builds up, which saves that precious factory floor space while still handling massive amounts of water. But on the right, the PWL model builds out, creating this huge surface area to float and skim off tons of heavy sludge, like the kind you'd find at a big food processing plant. Now this is just plain cool. The entire PCCS system fits inside a standard shipping container. Think about that. It means you can have a high-tech wastewater treatment plant delivered and set up super quickly at a remote mining site or a temporary construction camp or really any project that needs a mobile solution. It's basically plug-and-play water treatment. So let's talk scale for a second, because this is where it gets really impressive. That high-rate PCL model we saw a minute ago, it can process over 2,000 gallons of wastewater every single minute. Now, to put that in perspective, that's enough to fill a typical backyard swimming pool in about 10 minutes. It's incredible. So, we've seen the engineering, we've talked about the tech, but where does this actually matter? Let's take a quick look at where these DOF systems are hard at work out in the real world. I mean, the list of applications is just huge. We're talking about the food and drinks we all consume, meat, dairy, breweries, all the way to the fuel in our cars from oil and gas refineries. It's being used to make paper, in chemical plants, and even by cities to treat their water. This tech is just quietly working behind the scenes, making so much of our modern world possible. And this is important. This isn't some niche experimental technology. We're talking about hundreds of these systems installed all over the world. It is a proven, reliable, and globally adopted solution for a very global problem.
Which kind of brings us to a final thought. We started with this really messy, complex industrial problem, and we found an elegant solution in the simple physics of a bubble. It really makes you wonder, right? If we can solve such a tough environmental challenge with clever engineering like this, what other big problems out there can we solve with surprisingly simple ideas?